Okay, so today we're going to be talking about significant figures. And significant figures help us know how precise measurements are. Okay, and significant figures tell us how many digits of a number we know with certainty. So, significant figures, or significant digits, sometimes people will call them, they are, let me see how I said this in the notes. They are the digits known with certainty plus one estimated digit. Okay, that seems really vague and kind of confusing. When you see a few examples, it will start to make sense. But basically, let's take a look at, for example, it's kind of hard to see, this graduated cylinder. See how you can see lines for the 40 and the 41, 42, 43, 44, 45. We know those lines with certainty, so those are significant figures. We also could estimate a digit between these lines. Like I could estimate that I have 40.1 milliliters of water if I had a line like right between those two lines. So I'm going to show you some examples now to help you understand significant figures. Hey everyone. So I just want to talk to you a little bit about some examples with significant figures. So if you look at these pictures that I have right here, it's two graduated cylinders and they're both measuring a volume of water, but one is a lot more precise than the other one. You can see this one on the right here. This one is more precise. This one is not as precise. And so to report the measurements for these cylinders correctly, we need to use significant figures. So let's start with this one that's a little bit more simple. This one, whenever you're reporting measurements with significant figures, you include all of the digits that you're certain of. So I am certain that the measurement of this liquid right here is 6 point something. Like I'm certain that it's between 6 and 7. I can see that. So I would put 6, and then after the decimal point, I'm estimating. I can't tell for sure whether this is 6.4 or 6.5 or 6.6. So with significant figures, you get all of the digits that you're certain of plus one that you're estimating. So I would record for this one maybe 6.5 because that looks like it's right in the middle there. And if I put like 6.55, that would be incorrect because there's no way, I can't even tell for sure that it's 5, let alone 5.5. So I only get that one uncertain digit. Now this cylinder over here has more markings. So there are more digits where I'm certain. So I'm certain it's between 6 and 7, and I'm certain that it's 6.6 something because you can see the water is right on that 6.6 line. So I'm going to do 6.6, and then I get one more digit that I'm uncertain of. So I'm going to guess that it's maybe 6.61 because it looks like it could be a little bit above the 6 line. So this one just has two significant figures, one number after the decimal point, but because this one is more precise, I get to add 6.61. Okay, let's look at another example. Here's another cylinder. I want to report this accurately. So you can see I have lines. This is 35. This next line is 36. This next line is 37. So again, I'm sure that this is 36 point something. So I'm going to record 36. And then I get to estimate that last decimal point. So I think it's maybe 36.4. And that would be measuring that with the correct number of significant figures. It's not correct if you just put 36, because you have one more digit that you can estimate. So you have to have something after the decimal point. It would also not be correct if you put 36.45. So it's got to be 36.4 or 0.5 or 0.6 or whatever you think it is. Okay, let's look at rulers now. So this is a ruler in centimeters. So same thing goes for this that goes for the graduated cylinders. So if I look at where this line is, it looks like it's 6. It looks like it's maybe not quite to the 6.3. So I think it's 6.2 something. So I'm certain that it's 6.2 something because it has those little tick marks between the 6 and the 7. So I'm certain of the 6.2, but I have to guess on the next digit. It's pretty close to the 6.3. So I'm going to guess that it's like 6.29. That would be the correct number of significant figures for this measurement. Again, just to remind you, you include all the digits that you're certain of. So for this one, it's the 6 and the 2, and then one digit that I'm estimating, which is the 9. Let's look at a different ruler. Okay, this ruler is a little bit tricky. You can tell that it's 5 point something. Now, sometimes people think that I'm certain of the second decimal point, but I'm not. I have one tick mark between the 5 and the 6, but I can only be certain of that, or that first decimal point. I could only be certain of that if I had a tick mark for every single point after 5. So if I had 5.1, 5.2, 5.3, then I could be certain of that decimal point. But since I don't, I just have to guess. So it could be 5.6, it could be 5.7. I'm going to guess that it's 5.7. And that 7 is a guess. It's uncertain. So that's all of the digits that I get. I don't get another one. This one's just a little bit confusing because of that extra tick mark in the middle. It's helpful, but it doesn't give me an extra digit. Okay, let's look at just one more ruler. Okay, this one is tricky. This one is right on the 3. So your first instinct might be to just say 3. But if you do that, you haven't included enough significant figures because there are a bunch of tick marks. So we are certain, not only are we certain that it's 3, but we are certain that it is 3.0. Because there's a tick mark for 0, and there's a tick mark for 1 and 2 and 3. So I am certain of both of these, actually. So that means I need to estimate one more. So I could maybe estimate that it's 3.01, but I'm just going to estimate that it's 3.00. Okay, I know that one's a little bit tricky, but I put it on here because UVU has had questions like that on their test where they'll give you a ruler that looks like this, and they ask you to report the measurement accurately, and they would have options in their multiple choice. They would have 3.00, they would have 3.0, they would have 3, they would have 3.000, and you have to choose which one is correct based on the ideas of significant figures. So hopefully that makes sense. It makes a little bit more sense when I'm in class explaining it, but that's kind of what we're practicing today. We're practicing figuring out how to report measurements accurately using significant figures. Okay, so we've talked about determining how to report a measurement correctly using significant figures. Now we're going to start looking at measurements. Now I didn't put units after these, but I probably should have. When we're talking about significant figures, it's things that have units. So this could be like grams or kilograms or meters or kilometers. It could be any units, but when we're talking about significant figures, it should be stuff that has units. So here are how we can tell the number of significant figures in these numbers. First of all non-zero numbers, so anything that's not a 0, are significant. So all of these numbers would be significant. All of these. That means these are measured, or they're either measured or they are our one estimated digit. Okay, all zeros that are between non-zeros are significant. So these 2 zeros, they are significant because they're between the 7 and the 4. So we must have somehow measured them. They're not just placeholders. Okay, all leading zeros, so that's zeros at the beginning of a number, are not significant. So like these zeros right here, those are not significant. Okay, it gets a little bit tricky if we're talking about ending zeros. So zeros at the end of a number are significant if there is a decimal point present. And one that's actually written. Okay, so they're significant if there's a decimal point written, and they're not significant if no decimal point is written. Okay, so to show you how these rules work, we're going to go through these examples, and we'll figure out how many significant figures there are in each of these measurements. And this tells us which of these numbers we know precisely, or if they're just some zeros kind of like holding a place that we didn't actually measure. So all 5 of these numbers are not zeros, so they're all significant. So that one has 5 significant figures. Here we have 2 zeros, but they're in the middle of 2 non-zero numbers. So everything there is significant. So we have 4 significant figures. Here we have some zeros in the middle again, but they're between non-zero numbers. So again, everything here, all 5 digits are significant. Now here I have some zeros at the beginning, or sometimes we call them leading zeros. Those are never significant. Those are just holding a place for us. So there's only 1 significant figure there. Here, this one's a little tricky. These leading zeros or beginning zeros are not significant, but these 2 zeros between the 3's, these ones are. So this one has 4 significant figures, the 3, the 0, and the 0, and the 3. This one has zeros at the end, so we have to see, is there a decimal point written? No, there is not, so this one only has 2 significant figures. These zeros are not significant. So we probably didn't measure those, like we don't know that it's 4,700. It could be 4,701. We don't know. Those are just holding a place. Same thing right here, this 0 at the end, it's not significant, so there's just 2 significant figures here. But I have a decimal point in this number, and so these zeros at the end are significant. I actually measured them, so there's 5 significant figures there. All right, that is how you find the number of significant figures in a measurement. Okay, now for the next just like minute, I wanted to quickly explain why in a measurement like this, let's say I'm measuring in milliliters here, these zeros are not significant. If you don't care to know why, you can stop the video right now, but I think it's kind of interesting to know why. So let's say I was trying to report this measurement. All right, so I know that it's 4,000 and something, and I have to estimate the next number. So it's 4,000, and I'm going to say 700. Now, am I estimating these zeros exactly? Do I know it's 4700? No, I don't know these. These are not like numbers that I'm allowed to estimate, but I have to put those zeros there because if I don't, it looks like it's just 47. So that's why I keep using the term placeholders. Those zeros are not significant because they're just telling me that this is 4,700 instead of 47. But the only 2 numbers that I know with certainty or that I'm estimating are those 2.